Okay, so picking up where the first video ended here with glacial erosion, and we're talking about these glaciers and how they can reshape a valley, changing it from being more of a V shape to more widened out and a little bit flattened out and smoother. The glaciers also are going to cause a lot of things like lakes and reservoirs and depressions like that where water can fill up. So it's a lot of the reasons why we have those type of landforms in the northern part of the United States where glaciers at one time did cover that part of the earth. But we don't see those glaciers in more tropical areas, so while they do have a large effect on the surface of the earth, it is only in those areas closer to the poles where they do have a huge effect. Okay, we can see the glaciers here. This brings up a good point with global warming as we talk about the ice in the water, or the icebergs in water. They really don't affect the elevation or the change in the sea level, but the problem becomes that the ice caps that are on land, when they melt, they need to go somewhere. They go obviously downhill to the lowest possible point, and that fills up the oceans, and that does add a lot of water to the oceans, and that's what's increasing sea level around the earth. So when we talk about global warming, we talk about some of the effects that can have by changing the sea level. Sea erosion, waves crashing against the shore, can eventually carry rocks and sediment away, and we could see how some of these shorelines have very, very steep cliffs as the waves constantly wash away and carry that sediment and debris away from those shorelines. Soil erosion, flooding and wind can carry away topsoil, leaving the area not suitable for farming. When we look at kind of the Great Depression, and we look at the American heartland area where we do a lot of the farming, some of the dust bowls and dust storms that went through have really devastated that area, and there's some areas that are just coming back from that. So when we talk about soil erosion, not being able to plant is huge in terms of the food cycle and the food chain. One of the biggest things that happens with weathering is the breakdown of rock into things that could be used as a soil, and without soil we can't plant, so that really would have a major effect on the earth. Okay, a couple of review questions here. What's the main difference between weathering and erosion? Okay, we're going to look at B for this one, where weathering breaks down rock and erosion is going to move it. So weathering doesn't have anything to do with transportation. Erosion doesn't have anything to do with the breaking down of rock. It has to do with the transportation of the rock. Which of the examples is chemical weathering? Oxidation is our example of chemical weathering. Which of the statements is true? Wind can break down rock by chemical weathering. Nope. Water acid can break down rock by chemical weathering. Oxidation can break down rock by physical weathering, and plant roots can break down rock by chemical weathering. So again, B being the main one there, where the water acid can break down rock through chemical weathering. Oxidation would be an example of chemical weathering, it's not physical weathering, and plant roots would be an example of physical weathering and not chemical weathering. Wind would be another example of more erosion, but if anything, physical weathering, not chemical weathering. Next thing that we're going to look at is going to be taking that sediment and debris and then turning it back into stone. So when we look at pieces of sand like this, they get loosely compacted, okay, soon after they are deposited into like a basin area, and we looked at how to make some sandstone. Okay, over time that sand is going to kind of get a little closer together and compact. You can see the spaces that are here are not quite as large. If we go to the next one, they're going to get a little bit even closer, and then we're going to start adding what we call a matrix, going back to one of those vocab words, and that's kind of going to be the gluing cement that's going to fill the cracks in between these loosely packed particles of sand. As they get closer and closer together, that matrix is going to then be strong enough to hold them together and cementing them in place, and that's when we then get to this final one where we can see there are no gaps anymore, no spaces, because that's all filled, and we have our sandstone. We also did the same thing with silt, and we look at the size of the, with shale, and we look at silt and clay making shale, the size of the particles that make up shale in the place of sandstone, where we see larger grains of sand, and with the shale we see smaller, tinier particles of clay and silt. So that pretty much brings us to an end for this section as we wrap it up and get closer to our tests. If you have any questions, feel free to stop by in class and ask.